In this video we are going to talk about the vector problems. Before we move on though, I'd like to remind you of a few things. In vector addition, if this is the vector P and this is the vector Q, we write the resultant vector as the addition, placing the vectors P and Q tail to end like P plus Q, right? So another way of course expressing these vectors are if we have these points A, B and C. We discussed that in the first video. Then I could express this as AB plus BC is AC, the vectors I mean. So if we reverse this, this also means that AC is AB plus BC. And we said that this is about going from A to C. Instead of going, this way, we can go this way first and that way first, or vice versa. Scalar multiplication was about multiplying a vector, the values of the vector, by a scalar, by a number. So if this first vector is 3 to 2, right, and if I multiply it by a scalar, I get 6 to 4, as 2 times 3 is 6, 2 times 2 is 4. So it's going to be 1, 2, 3, 4, 5, 6 to 4, right? From here, what I can write is that 2 times the vector AB is equal to the vector CD. Or, if I substitute AB with its magnitude A and CD with its magnitude B, then I can write 2 times A is actually 2A, right? It's obvious here. I multiply this by 2, I get this one. So, right, I cleaned up the figure now, and I would like to show you this. If we have this relation between two vectors, CD equals 2 times AB, this number 2 could be anything. It could be a fraction, it could be a bigger number, right? But it doesn't matter. If we have one vector expressed as a scalar multiplication of the other, then we can say that these two vectors are parallel, so they don't intersect. So if you want to prove that two vectors are parallel, you must show them in a scalar multiplication relation, like this one, this equation. Or in the question, it could ask whether the points P, Q, R are on a straight line or not. So what happens is that if two vectors are parallel, then you can also talk about saying that they make a straight line. So if you're talking about the points, for example, P, Q, R, like this, let me say, this is the point P, this is the point Q, this is the point R. They make a straight line because the vectors PQ and QR are parallel. Now let's see some examples. ABCD is a parallelogram. Now AB and BC are given as P and Q. And in terms of P and Q, we're going to find the expressions for BA, AC, and BD. Now, BA is here from B to A. It's the opposite of AB in terms of direction. So if AB, or part A, if AB is P, this implies that BA is going to be minus P. It's just about direction. In part B, it's asking an expression for AC. Now, you can go to AC by, like, from A to B, one vector, and B to C, another vector. So if I write this down, this is from A to B, AB plus BC. All I need to write down is the expression. So AB was P plus BC was Q. So that's the expression for the vector AC. Now we're talking about BD. Well, we have to draw this on our own. It's not drawn on the picture. So it's going to be from B to D, this direction. So first I'm going to write down what BD is. BD as a vector is BA from B to A, and then A to D plus AD. Or alternatively, you could say from B to C and then C to D. It doesn't matter. It's the same thing. Now, what we need to know is that in a parallelogram, opposite sides are parallel. So if they're parallel, they also have the same length. So actually, I know that BC is the same as AD, which is Q. BA, I know from part A, that is minus P, so I'm going to now substitute these into this expression. BA is minus P, plus AD is Q, so I'm done. In this triangle, we are given AM and AN, like P and Q, and the first question is, find an expression for MN. It is this vector, and it's good that you mark this on the figure and put the direction on. We're going to write this in terms of P and Q. So MN, first of all, I must write this down. MN is MA plus AN. I go to here. So actually, if AM, as you can see, the direction is here. If AM is P, MA must be minus P, and AN is, well, it's the same direction as given, so it's going to be a Q. So it's going to be minus P plus Q. The second part says find an expression for BC. BC is here. From B to C, it is this direction. And the question says M is the midpoint of AB, N is the midpoint of AC. So this means MB is also P in this direction, and NC is also Q in this direction. So I'm going to write down BC as addition of two vectors from B to A. So it's BA plus A to C, AC. And I'm going to write down the expressions. From B to A it is 2P, but in opposite direction, so it's going to minus 2P, plus AC is 2Q. And I'm done with this. Use your results from A and B to prove that MN is parallel to BC. Well, I'll start with BC. BC was minus 2P plus 2Q. Now if I take 2 out, this will be minus P plus Q, which actually is the vector MN. So I can write this as 2 times MN. So I'm saying that BC, the vector, is 2MN. And this shows that BC is parallel to MN. And this is shown. Last example. Well, in this one, the diagram shows a parallelogram, and the vectors are given A, B, and BC in terms of P and Q. X is the point of AD for which AX to xt, the ratio is 1 to 2. So this is 1, this is 2. But we know in a parallelogram, opposite sides have the same length. So this is also 6q. So I can immediately write down that this is 2q and this is 4q. And here the same thing applies for the DC. Y is the point on DC for which dy to yc is 2 to 1. Since this is 6p, I can write like this is 4p and this is 2p. Now, AC is easy. It is just AB plus BC. So it's going to be 6p plus 6q. AD is the same as BC, so it's going to be nothing but 6q. We just talked about that. And DC is the same thing. We said that it's going to be 6p because it's the same as AB. Now XD is from here to here only. From here to here only, and it's this direction. We talked about it. We said that this is 4q. XD equals 4q as it is. Well, you can express this as 2/3 of AD, and then you can write down this is 2/3 of 6q, so you'll end up with 4q. Similarly, you can show dy is 4p because dy is 2/3 of dc, which you could write 2/3 of 6p, so that you'll end up with 4p. Now, xy here is xd, so let me write this down. Xy equals xd plus dy. Now, so you can go with this, this. Alternatively, you can go back and wander around like that, but this will be the addition of 4 vectors. It's going to be longer, not harder, but longer. Now, xd, as we know, was 4q. This just rubbed here. So it's going to be 4q, because it's this direction the same, plus, well, dy is this direction, so it's the same. There's no minus change, so it's going to be 4p. So that's what xy is. So basically, use the addition rule to show the expressions for the given vectors, and then for showing 2 vectors are parallel, or 3 points make a straight line, or on a straight line, you should use the scalar multiplication. You should show 2 vectors are parallel by expressing them in a scalar multiplication. I hope this helps. Thank you.